So, last class I have started settlement analysis example before application of building load. Actually, total settlement is settlement due to heave, it may be negative if I am considering settlement of immediate as well as consolidation settlement downward is positive. So, total settlement is settlement due to heaves, immediate settlement and consolidation settlement. Considering heave settlement is very small, it has been neglected. So, it is immediate as well as consolidation settlement. Then immediate settlement for cases of clay and for sand we have considered two theories of Buisman 1948, then another one is your Skempton-Bjerrum and Hartmann 1978. So, these we have covered. Now come to consolidation settlement. Consolidation settlement. Consolidation settlement, if I write it, rho C is equal to epsilon z into dz integration. So, epsilon z is equal to your vertical strain which is equal to delta E by 1 plus E 0, and delta E is your change in void ratio, which is equal to a function of P 0, P c pre-consolidation pressure and increase in stress due to external loading, that is your delta P. So, consolidation settlement generally it is C c by 1 plus E 0 H c log 10 P 0 plus delta P average divided by P 0. It is for normally consolidated soil. And which is equal to also Cs Hc by 1 plus E 0 log 10 P 0 plus delta P average divided by P 0. This is for over consolidated clays with P 0 plus delta P average is less than pre-consolidation pressure. Pre-consolidation pressure, how you will get it? So, that part has been covered in consolidation in soil mechanics also. Again it is Cs Hc by 1 plus E 0 log 10 P c by P 0 plus C c S c by 1 plus E 0 log 10 P 0 plus delta P average divided by P c. So, that means in this case P 0 less than P c less than P 0 plus delta P average. So, P c is your pre-consolidation pressure, C c is equal to compression index and Cs is equal to swelling index. Now, if you look at the consolidation theory, E versus log P, so for normally consolidated soil, it is Cc by 1 plus E0. Cc is your slope of your virgin curve, right. So, swelling index, coefficient of compression, this is a compression curve, this is excavation swelling, then this is recompression curve. So, Sc is your height of the layer, height of the soil, total height of the soil, it is your Sc compressed layer if it is a clay. Log 10 P0 plus delta P average by P0, delta P average I'll get back to you. This is for your normally consolidated soil or clay, normally consolidated soil, or you can write it clay. Similarly, for this part from here to here, it is Cs Sc by 1 plus E0 log 10 P0 plus delta PAV by P0. This is over consolidated clays, particularly when P0 plus delta PAV is less than is your pre-consolidation pressure. Then if PC is lying between P0 overburden and P0 plus delta P average, in that case it is Cs Sc by 1 plus E0 log 10 Pc by P0 plus Cc by Sc divided by 1 plus E0 log 10 P0 plus delta PAV by Pc. Let me draw a layer here, this is your clay layer and there is somewhere else, here it is your groundwater table, then footing is resting here. So, this will be Q0 and this layer, particularly this layer is your Sc or clay soils. Here if I draw it here, load intensity, and this is your delta P, then this comes out to be here, this part is your delta P L, delta P M, this is your delta P B, and this is your depth Z. So, from how do you get the average value? Generally average increase of pressure may be approximated delta P average is equal to 1/6 of delta L delta P top plus 4 delta P middle plus delta P bottom. The increase in stress, particularly in this soil layer, it is not a constant with your depth, rather it is decreasing at the bottom. If I write it, delta P T is your pressure increase at top, and delta P M is your pressure increase at middle, then delta P B is your pressure increase at base. So, delta P average you can calculate considering increase, particularly if this is your clay soil, this layer you want to find it out consolidation settlement, then find it out increase in stress at the top of the layer, at the middle of the layer, at the bottom of the layer, that means B. Then you can find it out delta P average is your 1/6 delta P top plus 4 delta PM plus delta P at the base. Next part is your Skempton modified your coefficient of means particularly consolidation settlement. This is your Skempton and Bjerrum modified consolidation settlement. So, it will be row odiometer, that means consolidations settlement from your odiometer test, that means from your consolidation test supposed to be integration of mv delta p into delta z. mv is your volume coefficient compressibility, volume coefficient compressibility. So, then you can find it out in the field taking into consideration of in the consolidation settlement in the field, it will be consolidation settlement in odiometer into settlement ratio. So, you can get it this MV from your consolidation test. I hope this has covered primarily in soil mechanics, particularly in your consolidation part. So, he further said, they further particularly based on the laboratory study, they further said consolidation settlement is your immediate settlement plus your mu into rho oedometer test from consolidation test. Mu is called pore pressure correction factor, mu is your pore pressure correction factor, pore pressure correction factor, and it depends upon your pore pressure parameter A, depends on pore water pressure parameter A. So, they have given graphical values also, from there you can take it. Generally for rough design for NC normally consolidated clays, the value of the correction factor is taken as 1.0 to 0.7. For over consolidated clay OC, the mu value has been taken as 0.7 to 0.5. Then for heavily over consolidated clay, this value will be 0.5 to 0.3. They have given certain charts, you can collect it in a book, Foundation Design and Analysis by Bowles, as I said. From there it is your settlement ratio, and this is varying from 0 to 1. Here also settlement ratio, this is varying from 0 to 1, and they have given for this chart is there. It is for circular foundation, circular as well as for continuous foundations. So, this is how it has been modified in the consolidation settlement. If I put it a summary, the consolidation settlement rho C is your epsilon z into dz, and this is your vertical strain, and it is delta E by 1 plus E0, that means change in void ratio. Delta is your change in void ratio, it is a function of overburden pressure, pre-consolidation pressure and increase in your stress. And consolidation settlement has been given for normally consolidated soil, over consolidated clay and over consolidated clay, particularly P0 plus delta PAV is less than PC. If PC is lying between P0 to this P0 plus delta PV, and these are the all three sets of equations, and from there this is your compression index, Cc is your compression index, Cs is your swelling index. Cc, this compression index you can get it from your Virgin curve, Cs you can get the slope of swelling, and recompression index you can get it slope from here. You can write it Cc, Cs, CRC, recompression or Cs sometimes said. This you can get it from your consolidation graph, E versus log P. Then how to calculate delta P average? It is 1/6 of increase in stress at top, then 4 times increase in stress at middle, then increase in stress at the bottom, then again it has been modified by Skempton considering your MV. This is your volume coefficient compressibility, you can get it directly from your consolidation oedometer test. And finally, they have suggested total settlement. Total settlement is your immediate settlement plus mu into oedometer settlement considering consolidations. Mu is your pore water pressure correction factors. Whatever the value you are getting for this case Cc by 1 plus E0, this is from your laboratory test. So, from the oedometer test you can find it out a settlement, that is basically from your laboratory test, and the pore water pressure corrections has been applied to simulate into true fact of your field. For normally consolidated clay it is varying between 1 to 0.7, for over consolidated clay it is 0.7 to 0.5, heavily over consolidated clay it is varying 0.5 to 0.3. Before I go to your stress path and other part settlement by the stress path methods, let us solve one problem, then we will try for different methods. One example, there is a case here, 0 meter here, this is your ground surface and there is a footing. Here it is your minus 1 meter, water table is lying here, this is your minus 5 meter, and beyond this it is a medium sand. N is equal to 20 and this width is your 2 meter, and this soil is brownish grey silty sand. Silty sand, gamma is equal to 18 kilonewton per meter cube, on-drain cohesion is your 50 kilonewton per meter square. From laboratory test Cc by 1 plus E0, this parameter getting 0.06, and find it out your settlement. Total load coming onto the footing is your 400 kilonewton. This is what is your example. There is a proposed site of 0 to 5 meter, water table is located at 1 meter below your ground surface, footing size is 2 meter. So, then the load, expected load from the column is your 400 kilonewton, and it is a brownish grey silty sand. Gamma is given 18 kilonewton per meter cube, undrained cohesion is given 50 kilonewton per meter square. Cc by 1 plus E0 from your consolidation test, it comes out to be 0.06. Now calculate, because this is a silty sand, calculate immediate settlement. Part 1, immediate settlement. In this immediate settlement, what is your formula? Qn into B by E 1 minus mu square into Ip. Ip is given, Ip at the center, it is your 1.12. Then you calculate your values, So, this is your rho I is equal to Qn. What is the value of your Qn? So, Qn you can always find it out, 400 by 4, it is a 2 meter by 2 meter, it is a square footing, 400 by 4, it is 100 kilonewton per meter square. Mu value is given 0.5, E you assume 600 Cu. Based on the Cu you can calculate E, modulus of elasticity, and from there this is your 100 into 2 divided by 600 into Cu value is your 50 into 0.75 into 1.12. So, this is coming about to be 5.6 mm. Then depth correction factor has to be calculated. So, this is your L by B is equal to 1.0 and dF by B is equal to 0.5. So, depth correction factor alpha is equal to 0.86. So, immediate settlement corrected, it is your 0.86 into 5.6, which is your 4.8 mm. Now come to your consolidation settlement. So, calculate P0. If you look at here, P0 water table is at 1 meter and below 1 meter, 1 to 5 meter, how long your pressure bulb you can calculate. You can take it into 2 times B. So, it will be 2 into 2 times, it will be here 4 meter, exactly it is at here. So, then calculate P0. So, P0 is equal to 1 into 18, 1 into 18 above the water table bulk unit weight consider, plus 8 into 2. Where is your 8 into 2? Submerged unit weight minus 10, gamma saturated, assuming this is your gamma saturated. So, gamma saturated minus gamma W 10 or 9.81, it comes out to be 8. Then here it is 18 plus 16, 34 kilonewton per meter square. Delta P increase in stress because of your rectangular loaded, because I have not covered that one. Stress, increase in stress because of your external loaded, that will be after your settlement. I just put it here For rectangular loaded, delta P is equal to 0.34 into 100. 100 is your load intensity, 100 kilonewton per meter square. It is your 400 kilonewton. Here it is 2 meter by 2 meter. This part I will discuss after your settlement. Then again I come back to this problem. So this comes out to be 34 kilonewton per meter square. So delta is equal to Cc by 1 plus E0, Cc by 1 plus E0 into H, then log 10 P0 plus delta P by P0, which comes out to be 72 mm. Then considering pore water pressure corrections, mu is equal to 0.86. This is your pore water pressure correction. Then it comes out to be rho is equal to 0.86 into 72, which is your 62 mm. Now immediate settlement is your 4.8 mm. So total settlement is equal to immediate settlement plus consolidation settlement 4.8 mm plus 62 mm. So 66.8 mm. So I will stop it here. Next class I will go by means of stress path method to find it out your settlements. Thank you.